There's a new technology that's quietly becoming the engine behind the entire AI revolution, the vector database. Now, that might sound super technical, but trust me, it's the secret sauce that is fundamentally changing how computers understand our world. Let's break down what it is and why it's such a massive deal.
And look, this isn't just hype or some tech buzzword. Companies are literally raising hundreds of millions of dollars to build this stuff, and for a really good reason. It's being called the essential database for this new age of artificial intelligence. So that's the big question, right? In this explainer, we are going to get right into it. What a vector database actually is, the magic of how it works, and why it's so incredibly critical for the future of AI. To really get why we even need vector databases, first we have to understand the enormous problem they were designed to solve. And it all comes down to the kind of data that, well, basically runs our world now. The scale of this problem it's just wild. Get this. Over 80% of all the data in the entire world today is what we call unstructured. So, unstructured, what does that even mean? Well, it's all the stuff you deal with every single day. We're talking about your photos, your social media feeds, all the videos you watch, podcasts. It's data that just doesn't fit neatly into the tidy rows and columns of a traditional spreadsheet. And that really shows you the old school challenge. With a traditional database, if you wanted to find a picture, you had to hope that a human being had manually tagged it with the perfect keyword, like dog or beach. The computer itself, it had no clue what the raw pixels actually meant. It couldn't understand the content, just the little labels we gave it. And this is where vector databases come swooping in. They basically perform this brilliant two-part magic trick that allows computers to finally make sense of all that messy, unstructured data. The whole process really boils down to just these two key steps. First, you create this thing called a vector embedding. And second, you index all of those vectors so you can search through them at like lightning speed. Okay, think of a vector embedding as a kind of universal translator for data. A machine learning model takes a look at a really complex piece of data, say a photo, a sentence, or a soundbite, and it converts it into a simple list of numbers. This list of numbers, this vector, captures the essence, the core meaning of the original item. So in this huge numerical space, the vector for king would be really close to the vector for queen, but incredibly far away from, say, cabbage, because the numbers actually get the relationship between the ideas. So once everything is just a list of numbers, a computer can do something it's amazing at, math. It can just measure the mathematical distance between any two vectors. And vectors that are close together represent things that are similar in meaning. This lets us find the nearest neighbors for any piece of data, which is really just a fancy way of saying we can find the most similar stuff in the entire database. Exactly. Okay, you might be thinking, if you have millions or even billions of these vectors, wouldn't checking the distance from your query to every single one of them just take forever? And you'd be right, it's totally impractical. And that brings us to the second part of the magic trick. Indexing. Think of it like creating a hyper-intelligent GPS for all of your data. It organizes those millions of vectors into a special, super efficient structure. This structure is basically a map, letting a search query instantly zip to the right neighborhood of vectors without having to waste time checking every single one. That's the secret that makes this kind of similarity search so unbelievably fast. Okay, so that's the how, but let's get to the fun part, the why. What kind of amazing, real-world superpowers does this technology actually unlock for us? The applications here are just incredible. Vector databases are what can give large language models like GPT-4 a long-term memory. They're the engine behind semantic search, where you can search for a concept or an idea, not just an exact word. You can finally search for an image using another image with no tags required. And of course, they power all those recommendation engines that suggest products you might like on websites. And hey, this isn't just a theoretical idea for the future. It's a rapidly growing field right now. There's a whole ecosystem of companies, Pinecone, Weaviate, Milvus, all building out this foundational tech as we speak. All right, so let's zoom out for a second and just think about the big picture. What does all of this really truly mean for the future of how we interact with information? This is the absolute key takeaway. We are moving from a world where computers could only match exact words to a brand new world where they can understand relationships, nuance, and context. For the first time, they can understand what data actually means. And that just leaves us with this one fascinating final thought. For decades, our ability to search for stuff has been totally limited by our ability to describe it with simple keywords. But now that that barrier is starting to crumble, what kinds of complex, abstract, and creative questions will we finally be able to ask our machines?